So we have Greg Estes from NVIDIA, the chip maker behind, it seems, everything AI. We'll let Greg talk more about that, and also the workflows that underlie a lot of the creative process going on in AI from a technology perspective. So please take it away, Greg.
All right, thank you very much. I've learned a couple of things here. The first of which is, if at all possible, don't follow Norm Holland. Great presentation, thank you very much, butthead. So I will try to be as a third as entertaining as Norm. And what I'm going to do is I'm going to spend some time talking about a lot of different aspects of artificial intelligence. Some of you may think of NVIDIA as a chip company that does graphics cards for gaming and whatever, and that is definitely part of our business. But we have about 3,000 engineers dedicated to artificial intelligence in a 12,000 person company, a lot more software engineers and hardware engineers. And so the software that we make is the underpinning of all of the major deep learning frameworks, which is how people build deep learning and artificial intelligence applications on there. So we're kind of Switzerland. We get to see some fun stuff from working with a lot of different companies, some of which have already been mentioned here, and I'm going to show you a few things that I think are kind of cool. AI has been changing the world in a lot of ways. We've been talking about M&E here, but if you're paying attention to science in areas like the Nobel Prize, the discerning gravitational waves, new forms of AI that are assisting radiologists to be able to spot cancer cells better than anything that's happened in the past. All of us know Alexa and the way that AI assistants are filling our lives with AI on a daily basis, really. I'm a huge Alexa fanboy, by the way. And one of the things that people think about a lot when they think about AI is self-driving cars, which again isn't media and entertainment, but something that a lot of people can wrap their heads around. Is kind of like one of the real cool things that AI is going to be able to do that eventually affects M&E quite a bit, because if you don't even have a steering wheel in the car, what are you going to do? You're going to probably watch entertainment, and so it comes wrapping around as well. I'm going to spend all my time on M&E except for one thing, and I want to show you a quick clip of some recent research that we did that hasn't really been seen widely. And this is the latest in self-driving cars. You'll notice, I probably won't show this whole clip, but he's driving 8 miles through backcountry, stop signs. It's a lot easier to do highway, by the way, than it is city driving, because the conditions change quite a bit, never touching the steering wheel. So the way that this happens is we're using AI to take in the different sensors, LiDAR and radar. You understand where you are relative to what's called an HD map. Then you understand where you're sitting, ego motion it's called, where the car is. And if you understand what's around you and where you sit, then driving turns out to actually be the easiest part of it. And one of the things about self-driving cars and driving is it's a lot of times thought to be like the hardest thing. It turns out it's a lot easier than robotics. Because with self-driving cars, you're largely trying to not hit something. That's basically what you're trying to do. But think about robotics. The one thing that you for sure want to do is you want to touch something. You want to manipulate it. You want to interact with the world. Much harder problem. So you'll see a lot of that coming. But I'm going to spend my time talking about media and entertainment today. The problems that AI is solving are really exploding, and coming with that, there's an explosion in the types of networks that are happening. AI doesn't happen with just one kind of network, and as a matter of fact, there are new networks and new types of networks and new models that are being generated all of the time. And you've heard a couple of the other speakers talk about that. For instance, if convolutional neural networks, that's good for images. Then you look at recurrent networks. Recurrent networks are important because you can't do speech unless you have a sense of time. Because what word comes before or after another word changes its context and changes its meaning. So now you have to have a sense of what is occurring in time. You don't need that with an image to understand whether there is or is not a bird or what kind of bird it is in that image. You don't need to have the context around it. It would be nice if you did, but you don't absolutely need it. There's a new kind of network, briefly mentioned earlier, called a GAN, Generative Adversarial Network. These are two networks that are trying to fool each other and get better and better at creating something. This is going to become important in just a minute in some of my examples. So think of it as perhaps an art forger and an art detective. The forger says, "This is a Picasso." The detective says, "No, that's not a Picasso. The brush strokes are wrong here." "Okay, this is a Picasso." No, that isn't quite right because of this and this and this. And they go back and forth and back and forth and back and forth. So now you have the idea that instead of understanding what something was that already existed, now you're creating something that's never existed before. Right? Now you're creating something completely new. I'll come back to this and show you some examples. Then reinforcement learning is where you learn by this is usually used, by the way, for robotics. Great example. There is no ground truth. There is no basis. You start from nothing, and it learns by, let's say, watching a human. Could be playing dominoes or doing something or other. And the sizes of these networks are getting huge too. What difference does that make for you? Largely nothing. Unless you're a company that is building your own data center, or unless you're one of the people that needs to invest in how much compute resources you're using in AWS or Azure or some of the places in the cloud. So if you're one of the people who's not on the creative side but is on the IT side, the fact that it takes a crap load of compute, that's a technical term, in order to do all this, and the sizes are getting bigger and bigger and bigger, it matters a lot. You have to throw a lot more compute at it as the problems are getting larger. Now, a company like mine, we benefit from that because we sell more GPUs or whatever. But it's something to keep in mind that the size of these problems is just getting larger all the time and things are changing. But the idea of an assistant, of a muse, has been around forever. This painting's 150 or so years old. I was working on this presentation. My wife said, naked women, guitars, dogs. Is this your idea of heaven? But the idea of the assistant, the muse, all of the things that influence the artist has been here kind of forever. I could have gone back 500 years and found the example as well. So I want to talk about some of that. And I'm going to start with the idea of digital content creation. And now what I'm going to show you is some research that our research team did. You can't buy this anywhere. I'm not trying to sell you anything. I'm just trying to educate you for fun. What this is we took a database of celebrities, and then we used a GAN, and we let that GAN work on it, and it created people that never existed before. Now we're morphing that just for effect to go back in between them. There's nothing about the morphing that has anything to do with any of this. The point is, the AI went in and created people that don't exist based around celebrities. And you know, we picked a few, could have picked a lot more, there's thousands of them. And by and large, you know, they're pretty good. And they're often very attractive. There was one towards the end of this I want my youngest son to date. You know, she's looking pretty good. What difference does this make? Well, there's a lot of times in advertising or other things that maybe you want a certain shot, a certain look or whatever of somebody, and you don't have a model like that. And sure, a digital artist can start with something and come up with something else. But to be able to do it instantaneous like that is a whole different thing. Kind of fun. Now, this is mocap. I would say probably vast majority of people here have had experience with mocap in their life. They probably don't normally do it where there's no dots that are required. There's no motion capture stage. There's no green screen. There's no whatever. It's just the AI seeing a person and being able to understand where they're moving. And notice the casting of the shadows in the back. It's being done in 3D as well. It's from a company in Canada called Wrench. This is something you can actually buy from them. It's commercially available. This one is an example of a new kind of network, phased function neural networks, for those of you that are techie and are paying attention. This, we're going to get a character. This is for game development, for instance. Could be for a lot of things. Let's say game development. The character is able to walk over all of those hills and valleys and actually cross over a bridge, and nobody animated it. It learns how to do it itself, and as it would climb up, my favorite part, it actually shifts its weight forward like a person would do. As you're going, you know, you're climbing over a rock, you got to move your, so it isn't just kind of weirdly animated. So these kinds of things are really going to help the person who's trying to create games and solve a lot of time for them. I don't think it's taking anybody's job away. It's helping them to do some of the work that might be more tedious and to get a lifelike look where you're talking about, it's the story that you're trying to do, not how characters climb around. This is, now I'm going to get into my kind of fix it in post. The next example, if the PowerPoint guides let it play, is going to be style transfer. Now you might have seen style transfer before. That's where you take a look, could be Picasso or Rembrandt or whatever, and then you apply it to an image. So there's been a couple of really popular apps on the App Store for Android and Apple that did it with single images, and now you're starting to see it with video. The so what here is we're actually doing it in 4K video at a lot faster speeds than I've seen before. So that's the kind of the thing that was worked on here. And that's cool. It's kind of cool, but it's a little bit of a special effect. It's more fun than it is practical. What I get excited about is this next one, and it's going to go kind of fast, so pay attention. This is from Microsoft research, and the idea here is to do style transfer so that you can do things that end up with a photoreal look at the end. Now, my favorite example here is imagine that you had a shot of the New York City skyline during the day, and you really wanted a night shot of that, and you wanted to do night for day or day for night. You're able to take, let's say, the Hong Kong skyline at night, apply it to the New York skyline during the day, and get the New York skyline at night. So check this out. And it can work on people too. The Barbie one at the end is my favorite. Pretty cool stuff, huh? And the reason I get excited about that is, gosh, every art department everywhere has somebody that's wanted to just create something out of, you know, take two shots and combine them. Just super, super practical as opposed to some other stuff, which is just kind of fun. All right. We've all, well, everybody, has anybody here never used Photoshop? All right then, okay, so you've used Photoshop, maybe you tried to fix something and you cloned it from somewhere else or used a heel brush or whatever. Okay, what if AI was able to fill in parts of an image that had been removed and they never existed anywhere else in the shot? So check this out. Bing. Now, pay attention. In this case, they're going to take the person completely out of the scene. Pretty cool stuff. They're using actually 3 different kinds of networks in this case. So they're using the GANs, and they're using a couple other networks as well, so that it's creating new parts that have never existed before. Again, not available today, but practical as hell, right? This is the kind of thing that I predict you're going to see in your next generation Photoshop type applications pretty soon. All right, moving on. Okay, this one's a little complicated, so I'm going to take a second. Ray tracing is computer graphics done correctly. I come from a computer graphics company, and you'll hopefully allow me to oversimplify for a second. But basically, the raster graphics that you see, all video games that you see, it's a cheat. It's a trick. It looks pretty good, but it's designed to go at 60 or 120 frames a second because games have to be real time. But when you see a light on a wall or something, it's pre-baked lighting. It's already done. The image has been taken knowing that the lighting was going to come from there, and so it looks correct. But you couldn't really move the light. You couldn't turn the lights on and off, right? You can't do that in a game unless you cheat in other ways to get it to look. But ray tracing, on the other hand, calculates every bit of light from every light source and how it bounces around. And people would have been using this for years and years and years, but they haven't because it's computationally very expensive. It's tough to do. It could take, well, there's stories about how Toy Story took 40 hours a frame or whatever, right? I mean, it's just, it's many, many minutes, maybe hours, sometimes days per frame to do it correctly. Well, when we're working on something that allows us to take the noise out of it, you're going to see, and it's a little subtle, I apologize on this, but see these speckles here? Black or white speckles on the left side of the image is where the ray hasn't resolved. It hasn't figured out where light has bounced anywhere. And you have to wait till all of that goes away before you have a proper image like you see on the right. So on the right side of the screen, we're going to use artificial intelligence to correctly, usually correctly, pick exactly the color of every pixel of what it would be had it been calculated correctly. But everything is coming from ray tracing and not cheating, if you will, because it's all based around the physics of how that light works. Okay. Now I want to show you about AI for creating music. And what you're going to see here and here, what's happening here is we fed a neural network, John Williams' Star Wars scores. Can you bring the sound up just a bit? And this is music written by that neural network. Now, it's not played by a neural network, it's played by people. And it wasn't orchestrated by the neural network. I think it's probably the next thing, right? So all the melodies and what goes into what and how it should flow and where your emotions are brought up and all of that, that's the AI. But whether that one part is done on a viola or a piccolo, that was done by humans still, right? So that's I think is pretty close to state of the art right now. Meaning the state of the art is not that you just push a button and you get a Star Wars level score out. That has to be done by professionals. It's still pretty cool stuff. All right, moving on. Now I'm going to talk about content where the content comes in, you didn't create it, and you're not fixing it. So like user-generated content, news and sports, that kind of thing for broadcasters. So what I'm going to show you here uses flowers. And it's just because that's a database that we had. But if you want, you could pretend that this was Olympic sports clips or something coming in, right? So you have content coming in, and you need to quickly identify what's in that content, right? Is that a ski jump? Is it this kind of a flower? Is it a whatever? And this kinds of thing people need to do all of the time, right? If you're in China, you need to do this to be able to figure out objectionable content because there's a lot of things that they don't allow to have over CCTV, et cetera, right? If you're I'll just make this up. I'm not talking out of class. Probably people here from ESPN. If you're ESPN or somebody kind of like that, you may want to have hundreds, thousands of hours of clips coming in of all kinds of sports programming from all over the world. And don't you wish that it could automatically find the one-armed high school football player who threw a 99-yard touchdown pass in Galveston, Texas, so you could get it on SportsCenter that night. So understanding what's content is coming in very rapidly is important. And you need to be, but it needs to scale, right? You can't just do it with like 6. So what I'm going to show you here is firstly the state of the art using the fastest CPU that's out there. And then I'm going to show you with some new software that we have of what this looks like when you accelerate it on a GPU. So this is, you'll see the demonstration. It will go to one of the scenes there on the flowers, and it will identify what kind of flower it is. And this is doing it now on the GPU, doing the same thing. And then it's going to show you on a, that's on one machine. So that's 8 GPUs doing that. So the technology of being able to bring images in this case, could be video, but bring images or video in and be able to do inference on it very rapidly is just changing so much just in the last 6 months, night and day. So something you should check out if that's part of the business that you're in. Some other folks have talked about this a little bit, and I think this is pretty interesting for a couple of reasons. One, this is a big company, SAP, who is doing work here on brand identification. It's called Brand Impact, and you can go buy this. So now they're looking at helping marketing departments. Let's say you're, I don't know, Toyota or somebody like that, and you're going to put your logo on a broadcast. Not only how often does that show up, but as you'll see here, if the PowerPoint gods let this video play, whoop, shoot, that was my fault that time. Try one more time. It's catching all of the different logos as it shows up on the car every time. Also on any watermarks, of course, will show up. But later on, you're going to see a heat map of exactly where it shows up in the frame. So you'd be able to know, does your logo often in the lower third? Right, there you go, right there. To identify all of that. So if you're the content owner, you can use this to sell to somebody who wants that logo exposure, or an ad agency, you know. Or if you're on the other side of it, you're Bank of America or Visa, or you know, whoever you are that wants to be a sponsor, you can find out how much exposure you're getting for all of that. This is new research for automatically animating a character. So what we want to do here is when you watch this, it was fed an audio file and nobody animated it. So you have a face, a skin face, and you just feed it an audio file and see what happens.
Listen up. The train yard warehouses is our main objective. Alexei, you and your men will do that. You have to go in and out very quick.
The avocado is a pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone.
The avocado is a pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone.
What is happening here, the reason you see that wonky language on here is it's being fed specific phrases that carry all of the different types of vowel sounds and mouth movement that you would want to have, which is why you get that weird thing to work. But again, the idea here is just feed it an audio file and you can animate a character from that. So the next thing I'm going to show you is this idea. So that is speech to text to animation, right? You start with just an audio file of somebody talking, gets translated into text, then plays into an animation that then plays it. The next one would be, well, what if we could localize the content by taking the same thing and do a translation of it? We'll see
皆
if
さん、
it,
こんにちは。GTC ジャパンへようこそ。僕の言葉を理解できますか？よかった。GTC シリコンバレーの後、日本語をずっと練習していました。どうですか？うまくなったでしょう。それにしても、ジェンセンさん、その革ジャン、かっこいいですね。
So there you've got the input being translated into Japanese to the output. So the thing that I think is cool about this is if you were doing sports broadcasting, let's say, you had a broadcaster come in, they're just talking into a microphone like we are. Imagine it coming out in Portuguese for the Brazilian market, or in French, or in Japanese in this case. So we are just a hairbreadth away from being able to put this together. So you've got this speech to text, text to speech with translation on the back end, and oh, by the way, animating a character. We just did the wireframe head here, but could have skinned it in a realistic texture, which is pretty cool stuff. So that's what I wanted to tell you about. I actually have 16 seconds left, which with all of the interruptions there, has got to be an all-time record for landing the plane on the runway. If you have any other questions about this, I've got technical papers and citations for everything. There's my email on there. Many of it is on our developer website, which is different than our commercial website. It's just for the developer stuff. And I'd be glad to answer any questions, not now, but when you get back to me from that. And that's it. Thank you very much.